Hey everyone, Nick DeRobertis here, teaching you financial modeling. Today we're going to be talking about an introduction to sensitivity analysis. This is part of our lecture segment on exploring the parameter space. So we introduced last time what exploring the parameter space means, basically trying a bunch of different inputs in our model and looking at how that affects all the outputs and trying to gain a deeper understanding of the problem that we're modeling through that process. So, sensitivity analysis is one of the three approaches we're looking at in this course, along with scenario analysis and Monte Carlo simulation. And we're going to dig into formally what sensitivity analysis is. So, as with all the methods, the general process is we're running the model a bunch of different times with different inputs, and we're going to get the outputs from each of those runs, keep them all linked together, and then visualize all that at the end. That's true for all the three approaches, but there are differences with each of the approaches and how they're carried out. So for sensitivity analysis, here would be the formal definition, and just reading this, it may look scary, but really it's just a process that you have to follow, and it's fairly straightforward once we actually get into how to apply it. It just looks a little bit more complicated in like math and algorithmic terms. So what we're doing in sensitivity analysis is for each one of the inputs, we're going to choose a set of possible values for that input. So say it's interest rate. You might say it could be anywhere from 3 to 10%, 3, 4, 5, 6, 7, 8, 9, 10%. Those would be your values. And you would want to do that for multiple different inputs, whatever makes sense to analyze in your problem. Step two is then to look at all the different ways that you can combine each of these input values. So formally, that's called a Cartesian product, and that just means so say let's make it a little bit smaller and say you're looking at 5, 6, 7% interest rate, and then we're going to look at demand of 1,000 units, 5,000 units, 10,000 units. So it would be the 5% rate with the 1,000 demand, and then the 5% rate with the 5,000 demand, and then the 5% rate with the 10,000 demand, and then the 6% rate with each of the three demands, and then the 7% rate with each of the three demands. So 9 sets of inputs altogether for 3 of the interest rate and 3 of the demand. So however many values of each of the inputs, if you just multiply the number together, that should be how many runs of the model you have in the end, sets of inputs and outputs. So you've got all those values combined together. So then step 3 is to run the model. And it's saying just run the model for each one of these different sets of inputs. Then step 4 is, as you're running the model, store the output from the model along with the inputs. Since we're running it so many different times with different inputs, you got to keep everything linked together. And then number 5 here is then to visualize the results. So we have a bunch of numbers coming out. We have to make that more easily understandable. And so we do that through visualization. So hopefully just talking through it made that a little bit more concrete, but let's look at an actual example problem and how we would apply it to go even further in that concrete direction. So let's keep talking about demand. Here we have a simple demand model. So the entire model is a single equation here. Just demand equals a constant minus the elasticity of demand times the price. And that's kind of a standard demand equation. So here we had on this slide, x's are our inputs, right? And so here x is going to be the demand constant, the elasticity of demand, and the price. Those are our 3 inputs into the demand model. And the output, of course, is the demand itself. So let's go through those 5 steps now, or at least the first 4. So the first step is to choose values of each of these inputs that we want to look at, whatever is the range of reasonable values for the inputs. You typically want to go for whatever the full range of reasonable values are. Take kind of the lowest and the highest values that you think would be reasonable to see in the real world, and then you can see the whole range between them. So here, just taking 2 demand constants, 2 elasticities, and 2 prices, and those are our values we're going to use in the sensitivity analysis. Then step number 2, again, that Cartesian product, or in simpler terms, just combining all the inputs in every way that you can. And so we get that table there at the bottom. So it has, for the 60,000 demand constant, we're going to see every other possible combination of input values. It's with both the 200 and the 500. It's with both the 50 and the 100. And so we have all those combinations. Same thing for the 100,000 demand constant. And you can see that we've got it right because we've got 2 of each input, and so it's 2 times 2 times 2 is 8 total input cases, and that's indeed what we have here. So then going to step 3 is to run the model, and step 4 is to keep those things linked together. So we can kind of do all that here in this table, and now we have calculated this equation for each one of these sets of inputs. And by using this table, we've kept them mapped together, which inputs go to which output. So that was our whole sensitivity analysis process right there. Really not complicated. The only remaining step is then to visualize that. It's kind of hard to just look at this and be able to extrapolate meaning out of it immediately because it's a bunch of numbers. So we're going to look at ways we can make this easily understandable to where you can just glance at it and immediately see meaning out of those large amounts of numbers. So we'll come back and actually visualize that when we look at the applied examples in Excel and Python. And that's going to be the focus of the next lecture video, is to actually implement sensitivity analysis in Excel. So thanks for listening, and see you next time.